discussed about how to create an array and how to access the element in the array, correct? And the array name itself gives a base address. That's a very important point that we discussed. And then to access the array in the assembly language program, we should need three things. One is the base address of the array. Another one is the index, that is which loop index or the position of the element in the array that is needed, and the third one is what is the size of the data type of the array. If we know these three values, we can compute the address of the particular element in the array. So I taught you how to compute the address of the particular element in the array, and then we had computed quite a few elements and its addresses. Okay, and in today's class we are going to discuss about conditional instructions. Okay, first we'll discuss about conditional instructions, and then we'll discuss about using conditional instructions, how we write the proper assembly code. Okay, so this is the main thing for the today's class. So first, one second. So first I will ask two questions. What is the size of this array? The array name is called as add. Add is the name of the array. What is the size of the array? How many elements are there in this array?
Three.
3 elements. It starts with 0, 1 and 2. Okay. So what is the address of the second element? What is the address of the second element?
104.
Excuse me, I had given only add. Okay, I didn't give 1000. And add, it is of integer data type. Okay, the elements of the array are of integer data type. Okay, now my question is, what is the size of the, what is the address of the second element? So what is
the base address?
Yes?
Add plus 8.
The base address first.
Base address plus, yes, very good. Add plus
8.
Yes, very good. Add plus 8. Add base address plus index multiplied by size of the data type of the array. Index is the second position. Size of the data type is integer and its size is 4. So 2 multiplied by 4, that is 8. Base address plus 8. Array name itself gives the base address. So add plus 8. Okay, very good. Now in today's class we are going to discuss about if we want to access like all the elements of the array. That means, what I mean is, if you want to run through the array. Okay, first I want to access the 0th element, next I want to access the first element, next I want to access the second element. So basically I want to access all the elements in the array. So what to do for that? That's one only we are going to discuss in today's class. Okay, so before that I want to explain you one more concept that is named as we discussed all the arithmetic instructions and we discussed logical instructions, right? And all these arithmetic and logical instructions will come under data processing instructions. And we studied a data transfer instruction. And the third type and very important type of the instruction is nothing but the conditional instruction. Okay, so in today's class first we'll discuss about conditional instruction. So what are all the different conditional instruction? All the things we will discuss in today's class. Okay, so first, why we need a conditional instruction? What is the purpose of conditional instruction? So when we are doing some operation, we need to perform some checking, whether we reach the maximum value or whether the value is less, whether the value is equal to 0 or not equal to 0. We want to do some conditions. Okay, we are doing some computation. Based on the computation, we want to do some comparison. Finally, based on the comparison result, we want to do some operation. Correct. So let us take an example like in all of our houses we are having this tank level monitoring system, and most of our houses we are having automatic motor to switch on the motor when the water level goes below the threshold. Correct. So in our sump it will just in our tank it will just keep on checking if the water level goes below the threshold. That is, if it goes down a particular level, then the motor will be switched on automatically. This is the operation is there available in most of our houses. Correct. So basically there is an embedded system to do this operation. What the embedded system does is it just keep on checking the level of water in the water tank. And it reads the water level and it compares it with the threshold level. The threshold level is nothing but the minimum water level. Okay. If the water level in the water tank goes below that level, then the motor will be switched on automatically. So the processing here is the water level is read, and the second processing, the water level is compared with the minimum water level. Okay. So that we call it as threshold value. So if the value is less than or equal to the minimum threshold value, that's a value what we read is less than or equal to the minimum threshold value, then our motor will be switched on automatically. Okay. So here we are doing a comparison. Based on the comparison, some operation is performed. Okay. Similarly, this is a real world example. What I said is a real world example. Similarly, we are doing in our computers also, there are so many comparison operations will happen. After that, we do some computations. Okay. So how are we going to compare and how are we going to judge the results? Like how to perform the compare operation in the assembly language. That's what we are going to discuss. We are going to perform the compare operation or the condition operation using this conditional instructions. Okay. There are so many conditional instructions available. We are going to perform the operation using the conditional instructions. Okay. So first thing and a very important operation is first we have to perform the compare operation. Compare. After that the same LBW will come. So now source comma destination. What is the meaning of this compare instruction is? The meaning of this compare instruction is this. The source value is subtracted from the destination. The source value is subtracted from the destination. And what is the difference between this compare instruction and the subtract instruction? Anyone? I just explained the meaning of the compare instruction is the source value is subtracted from the destination, and in the next line also I had written destination minus source. What is the difference between this compare instruction and the subtract instruction? Anyone? By looking at the meaning, can you able to find out what's the difference?
Ma'am, subtract is source minus destination.
No.
Then I don't know.
Okay, no problem. Next. See, generally how we write that? Destination equal to destination minus source. Like that we write. No. After the computation, our destination will be updated. Correct? That is the meaning. For all the arithmetic operations and the logical operations. But only for this compare instruction, the source value is subtracted from the destination, but the destination won't get updated. Okay, there won't be any change in the value of destination and the source. Only the change is the source value is subtracted from the destination. Okay, but there won't be any change in the other values. That is the meaning of this. Okay, you all got it now? I repeat, in the subtract instruction, source value is subtracted from the destination and the destination value will be updated. That is the meaning of subtract instruction. In the compare instruction, the source value is subtracted from the destination and the destination value won't get updated. Even the source value also won't change. Okay, only the thing is subtract operation is performed. Then your doubt will be, then why do we have to do this? This compare instruction perform the subtraction and then it will set some flags. Okay, there are some flags that we are interested. Okay, so those flags are, let us take if the result of the subtract instruction is 0. If the source value is also 10, destination value is also 10. So if we subtract, what will happen? 10 minus 10 is 0. We will get the result as 0. So the this compare instruction, what it will do is, if the result is 0, it will set to the 0 flag. Okay? If the result is 0, it will set to the 0 flag. Okay? Similarly, if we are getting the negative value as a result, suppose if I am doing 10 minus 20, that means that we will get minus 10 as a result. If we are getting negative value as a result, then negative flag will be set. Okay, so like that, there are some 5 flags that we are really interested. They are negative, 0, carry and overflow. Okay, in addition to that, parity is the 5th one. Okay, so in today's class we are going to discuss about all these things. Okay, so now I just given an overview of compare instruction. The compare instruction performs the subtract operation, but the source and the destination value won't change. Why do we have to do this? This compare instruction will set the flags. The flag is the one that we are interested. There are 5 flags that we are really interested. Those flags are negative, 0, carry, overflow and parity. These are all the 5 flags that we are really interested. Okay. So first I will show all the things and then, okay, see here. Okay. So the conditional branches, there are many bits in E flags. So where these flags and all will stored? It is stored in the E flags register. Okay. And there are many bits in the E flags, but we are really interested in only in this 5. First is the carry flag, and next is the overflow flag, and next is the parity flag, next is sign flag, and next is 0 flag. So what is the meaning of 0? When the 0 flag will be 1. So the 0 flag is nothing but the 6th bit of this E flag register. The E flag register is 32 bit. In that the 6th bit is the 0th flag. Okay. So if the compare instruction gives the value 0, that means that both the source and the destination are the same number, then when we doing subtraction we'll get 0 as the result. So that time the 0 flag will be set to 1. Okay. When the 0 flag will be set to 1? When the source and the destination instruction both are same, then that time the 0 flag will set. Okay. I want to show one program. Are you able to see my screen? Now I had shown the Word document. Are you able to see it? Are you able to see it?
Yes, ma'am.
Okay.
Yes.
So, yeah, thank you. So, first is in this dot section dot text dot global underscore start. These 3 lines are common. Okay. What happened? Okay. So, first in this, move L15 to EAX. We are moving the value 15 to EAX register. Move L 15 to EBX. The value 15 is moved to EBX register. We are just doing compare EAX EBX. The meaning of this is the value EAX is subtracted from the value EBX, that is 15 minus 15 equal to 0. So I had given the instruction, you have to see this JE. What is the meaning of JE? Jump equal. Okay, JE stands for jump equal. I repeat, J for jump, E for equal. If both the values are equal, then it will jump to this location equal. Okay, so equal you can see here separately I had given, that is the label. Okay, the label is nothing but it is a location where we are going to jump. Jump equal to this. If it is equal, it will jump to the location EQUAL. You can give any name for this. Instead of EQUAL, you can give any name. Okay, if both the values are same, it will jump to this location equal. In equal, what I did, I moved 1 to ESI register. Okay, the ESI register will get the value 1. After that, I had given the terminated instructions. Okay, so now when I execute,
Ma'am, sorry
yes,
to interrupt.
yes,
You wrote CMP.
yes,
Isn't it CMP L?
yes, L is there. Yes, I missed it. CMPL.
Yes, ma'am.
You can give L, P, W, everything it will take. Okay, here it has to be L, but simulator didn't show anything, so I didn't check it only. Okay, but it has to be L. Okay, good. So now we'll see what happened after executing this instruction. I guess this is line number 7. 6, 7. So compare instruction is in line number 7. So I had set the breakpoint at line number 7. Yes, it is in the line number 7. I set a breakpoint at line number 7 and I want to show the things. 1 second. The images are overlapped. How to remove this overlapping? It is not working here. Okay. Okay, no problem with that only I'll explain. Okay. So first you can see here compare EAX with EBX. Before executing this instruction, the value of EAX is 15, value of EBX is 15. And I told another important thing, E flags, correct? In E flags only we have to see the results. We are interested in only 0 flag. When the 0 flag will set, when both the source and the destination are same value, then 0 flag will set. You can see this E flag, here only IF is there. That means that it is interrupt. Okay, it is interrupt flag is enabled and we are not interested in interrupt flag. Okay, so now if I am giving N, that means that compare instruction is executed. After executing this compare instruction, now what happens? Subtraction is performed. And based on the subtraction result, our E flag will be updated. Okay, you can see here, anyhow it got overlapped, so no problem, see this. You can see here in this whatever I am highlighting, E flag equal to PF, ZF and IF. Okay, the meaning of this is the parity flag is set. P stands for parity, F stands for flag. Parity flag is set. ZF, Z stands for 0, F stands for flag. 0 flag is set and IF, interrupt flag is set. Okay, so we can see that the result of the compare instruction is 0. Here before performing compare instruction in E flag only one flag is enabled. After performing this compare operation, that means that subtraction is performed and the result is 0. So based on that, now you can see that the 0 flag is set. Okay, this is how you have to see. Okay, this is how you have to find out whether the result is 0 or not. Okay, now after that, now what will happen? Your execution would have jumped to the location equal, correct? So till here it will till this compare instruction, it is same sequential execution. First it will execute the MOVEL 15 to EAX. Next it will execute the 8th instruction, that is MOVEL 15 to EBX. Next it will execute the compare instruction. After that, when it comes to jump equal, that means that based on the previous compare instruction, it will decide whether to execute the next instruction or jump to somewhere. Okay, so this is a very critical point. In this place only decision happens whether it has to execute the next instruction or jump to somewhere. So now in this instruction jump equal, when the condition is satisfied, it has to go somewhere for execution. Okay, so jump equal, it has to go to the location equal. That is not the next instruction, it has to jump to some other location. So here you can see that after this, it will execute 1 to ESI register, 1 to EAX, 0 to EBX. Now you can see the result. Here ESI register is 1. That means that it jumped to the location equal, and there we had given ESI is equal to 1. That instruction is executed. Okay. So before that you can see the value of ESI is 0. Okay, so before that it was doing the sequential operation. After the condition satisfied, it had jumped to other location. Okay, so you have to be very clear in the jump concept, and you have to be very clear about JE. What JE stands for? Jump equal. What is the meaning of equal? It is if both the values are equal, that is the operation performed by the compare instruction has to be, the subtract operation is performed by the compare instruction, and the value of the subtract instruction has to be 0. Okay, then only this condition will be satisfied and it will jump to other location. Okay, so here you can see that. So now I had explained about 0 flag, and there is sign flag, there is overflow flag, there is carry flag. Okay, and then there is a parity flag. Okay, so sign flag means what, and then parity means what, overflow means what, and carry means what, we will discuss. Okay, so first, what's the meaning of this overflow flag? When we add two positive values and we get a negative value as a result, then overflow flag will set. Okay, I repeat, when we add two positive value and we get a negative value as a result, yes, it will happen. I'll take one example and I'll show this in the lab demo. Okay, when overflow flag will set, I will show in the lab demo. And when carry flag will set, this is the extra value, right? If we add two 32-bit numbers and we are getting one more number as a result, 33 means we are getting one more number, that is we are getting a value for the next 33rd bit, then we call it as our carry flag. So I will show one more example when carry flag will set. Okay, so similarly you can check for parity and you can check for sign also. So what are all the other operations we know is, first we have to, in today's class we are discussing about jump equal, jump not equal. That is jump JE, JE stands for jump equal, when this will set, when the 0 flag is 1. This what I had explained you till now. JE, when it will come, JE stands for jump equal, when this instruction will execute, when the 0 flag is set to 1. Okay, that means that both the source and the destination value of the compare instruction is the same. That's the meaning of this. Okay, so similarly there are so many instructions given. So opposite to jump equal is jump not equal. When this will be performed, when the source value is not equal to the destination value, this will get satisfied. Okay. So first we will discuss about jump equal and then we'll discuss about jump not equal. When both the concepts are clear, then we will discuss about what is the meaning of jump above or equal to, below or equal to, carry. All the things we will discuss. Okay. So this is the things for today's class. And one more thing what I want to discuss is there are unconditional branches also. That means that first example is jump to the location. If we are just giving jump and the label, it will jump to the location and it won't come back. Okay, and the next is the call. The call is for, it is like the function call. It will go to that location, do the computation. Finally, it will come and execute the next instructions. Third one is the interrupt. Okay, so in today's class we discussed only about the conditional branches, that is, and in that also particularly we discussed about condition. As I told, there are conditional branches and we discussed about only zero flag. Okay, because first we have to clear with one concept, that is zero flag, and then we can build the remaining things on top of it. Okay, and one more thing I want to show is another example. Okay, this is with greater than or equal to. So before that I want to ask few things. Are you able to understand? Is that clear? What is compare instruction? What is jump equal to? Whether these both the concepts are clear? Any doubt in this? Any doubt in this? Please respond. No, are you able to understand? Any doubt in this? Instruction to access the elements in the array. As I already told from the beginning, there are three types of instructions: data processing, data transfer, and conditional instructions. If you are able to understand these three instructions properly, 75% of the assembly language is done. Okay, and remaining 25% is nothing but writing logic. And I know that most of you are very good in writing logic. This one I got feedback from your first year teachers, though they told that you are very slow in getting things, but I didn't feel like that. I felt you are pretty okay, but there are quite a few students in this class, they are very slow. That is, means that fact I have to accept it. But rest all are pretty okay only. Even in first lab itself, many are scoring full, so that is fine. It's good. If you start doing, like if you are able to understand this conditional instructions and this compare instructions clearly know, then that's all done. Assembly language program, you are the king or queen. Okay? It is these three are the base. This base is known, means 75% is done. Remaining 25% is writing logic. Writing logic is nothing but, if I am giving a program, if you are able to write simple English statement algorithm, I repeat, if you are able to write the algorithm in simple English, not pseudocode, but simple English is fine. Okay? Then that is remaining 25% is that. Okay, why simple English? If you are writing in simple English, and with that we can translate it to the assembly language easily. That's all our assembly program is done. Okay, so if you are able to understand all these three things properly, then you can, like you can take a pride or whatever it is that I am a very good assembly language programmer. Okay, you will understand it slowly. Why am I saying all these things? Okay, So I guess you started solving lab 2 also, because I had seen quite a few messages asking doubts about lab 2. It's nice to see. And yeah, it is like they were asking very good doubts also. Yeah, it's fine. But only one thing is like this, that everybody has to solve. That's what my expectation is. It should not be like 1/3 of the class or 2/3 of the class. Like everybody has to study. Correct, because you are at home only, there is no traveling time, nothing means all the time, I should not say like this, all the time you are free. Correct, other than attending classes, there is no job, no traveling time or no waiting in the bus stop or whatever it is. Correct, it is except few are traveling to attend online classes, yeah, they are there, sorry to say this, but yeah, others are all enjoying, right? So what I'm saying is show some interest, take some interest to learn these things. Okay, okay. Now we'll go back to our subject. So now, okay. So now let us take okay, so there are how many elements are there? 0, 1, 2, 3, 4. How many elements are there in the array? How many elements are there in this array? 6 or 7?
7.
7.
Yes. Because every time, this is the doubt that students will get, and the worst thing is like they will give 6 as the result, and when doing computation it will it means you won't get answer properly. That will become a major bug in the program. Okay, so array means it is having 7 elements and the range is from 0 to 6. Okay, it starts from 0, ends with 7 minus 1. Okay, that's how you have to remember this. So the base address of the array, let us take, I'm just writing matrix. That matrix is the name of the array. So the name of the array is nothing but matrix. So matrix is the name of the array, and then I want to initialize the elements. Okay, let us take that the array is having some junk values. Okay, so these are all the values in the array. Okay, let us take this array is having 1, here it is 4, here it is 8, here it is 7, here it is 11, here it is 25, here it is 3. Okay, there are some values in the array, but what I need is I want to change all the values to 0. Okay, so now we are going to write a program to do these things. What I need is I want to change all these values to 0. Okay, so first thing what do we have to write is first we have to get the address of the 0th element of the array. So move L, the address of the 0th element of the array, as I told, the base address, comma, open bracket, and then you have to give one space and comma. I told no, it takes 3 arguments. Offset is empty, we are not using it, and next is the loop index. That loop index, after that it is one more comma, it is 4. Correct? And I want the move value to EAX. 1 second. Okay. So now before this, I want to get the loop index. Correct. So I am moving L dollar of 0 to percentage of ECX. So the meaning of this is ECX contains the value 0. Why are we moving 0 to ECX? Because I want the ECX to be my loop index. With the ECX, we are going to run through the array. Okay. So initially ECX contains 0. After that it will take 1, next it will take 2, next it will take 3, next it will take 4, next it will take 5, next it will take 6. After that it has to get terminate. How it is going to terminate, that's what we are going to discuss now. Okay. So now the meaning of the second instruction is a matrix that gives the base address of the array. We are going to add it with 0 multiplied by 4, that is 0 only. So the element in the 0th element of the array, that is nothing but 1, the value is 1, it is moved to EAX register. Okay, the value 1 is moved to EAX register. And what is our purpose? We want to move 0 to this location. Correct. We want to change this 1 to 0. That's what we are discussing. Correct. Our requirement is I want to change this 1 to 0. That is my requirement. 4 to 0, 8 to 0, 7 to 0. Okay. And 11 to 0. 25 to 0 and 23 to 0. This is our requirement. Correct. So to do that, what do we have to do? Again, so here we have to write this instruction, move L dollar of 0 to, we can write a matrix percent comma space comma percentage of ECX comma. So what's the meaning of this? The value 0 is moved to the matrix. Okay, that is this location. What is this location? It points to the 0th element. So after this, the value in this location, that's the value in the 0th element becomes 0. Okay, that's what we are doing, right? Moving 0 to base address plus ECX is 0 multiplied by 4 is 0. So we are moving 0 to the 0th element of the array. Okay. Now what do we have to do? We have to make the array index to point to the next element, that is the first element. Okay. So how to do that? How the operation is add L dollar of 1 to percentage of ECX. The meaning of this is ECX value is having 0 and we are going to add 1. So 0 is added with 1, we will get the result as 1 and ECX value will be updated with 1. That is the meaning of it. Okay. And after that, we have to compare this ECX value with the size of the array. Okay. Because we don't know, right, whether we reached, whether we had compared all the elements or whether we had changed all the array elements to 0 or not, we are not aware of it. So first what we are doing is we are going to check whether all the elements of the array are changed or what. Okay. So 1 second. So now we have to compare percentage of ECX. With which value do we have to compare? So we have to compare it with this size of the array. Do we have to compare it with 6 or 7? Which value do we have to compare? See, the thing is, we have to compare the loop index with the size of the array. Okay? And now the value of the loop index is 1. Okay? That shows that one element in the array is changed to 0. Okay, so now we are comparing dollar of 7 with percentage of ECX. Why we are comparing it 7? There are 7 elements in the array, so we are comparing it with 7. Okay, though its range is from 0 to 6, but there are 7 elements in the array, so we are comparing it with 7. If it is jump, if it is equal, then it will jump to exit. If it is not equal, now what it has to do? If it is not equal, again it has to go do the computation again, correct? So it has to read the next element and do the things. So if it is not equal, it has to jump to loop. Okay, so where is the loop starts? The loop starts from here. Okay, I'll write where the loop is starting. So the loop starts from here. Okay, this is the starting point of the loop. So now you can see what's the value of ECX. ECX is 1 here. So base matrix plus 1 multiplied by 4, that is, it points to matrix plus 4, that is pointing to the first element. The first element is moved to EAX register. After that, what we are doing is we are moving 0 to the first element. Okay, and you can ask, why do we have to need this statement, ma'am? Why every time we are moving the value of the element in the matrix to EAX? It is not needed, but this is a double way confirmation. We can say that, okay, there are some elements in the array and we are changing it to 0. Okay, so one way it is to show the results, it will be easy, or else this first line is not needed. Okay, so now we are moving 0 to the first element of the array, and then we are adding 1 to ECX. Now ECX become 2. Okay, we are comparing 2 and the 7. It is not equal. So if it is not equal, it has to go to the loop. In the loop, what it is doing? Now the value of ECX is 2. So now the second element of the array is moved to EAX, and we are moving 0 to the second element of the array, and value 1 is added to the ECX register. Okay, so I guess it's timeout. Okay, so we'll stop here. Again, I'll maybe tomorrow we'll meet. No, that time I will repeat this. Okay. We'll stop here. I'll repeat this tomorrow. So any doubts? Any doubt in today's class? Any doubts? Any doubts? Please respond. Any doubts? Are you able to understand? Am I going very fast? Are you able to understand?
Ma'am, I'm getting few requests stating that few people aren't understanding. So if it is possible, can we do a rerun through this tomorrow again?
What?
I got couple of requests from few of my classmates stating that they are not understanding.
Okay.